Welcome to Space Terminal, the show where we sit down with leaders defining the next century of space infrastructure. Today, I'm joined by Nestor Levin, an officer at the United States Space Force. Our listeners are leaders, operators, officers, and partners building frontier technologies. Welcome, Nestor. Why the Space Force? How did you get here?
It was pretty unconventional. After graduating from the Air Force Academy and doing my master's, I came to Los Angeles as a Air Force officer, though assigned to a Space Force billet or an assignment. And so when I first came to the Space Systems Integration Office, it's here at LA Air Force Base, the unit that I was in got moved over to something called Task Force Futures, which is putting together this new organization in the service that's meant to define what the next 10 to 15 years of the Space Force ought to look like. From that role, I've found myself being a liaison with SpaceWERX in the Commercial Space Office and trying to bring together different government partners and stakeholders to collaborate on different opportunities and extending out that demand signal to our industry partners and investors alike.
Commercial space today is a visible force multiplier. Without discussing classified ops, what is the United States Space Force's role in today's paradigm compared to, say, 5 years ago?
Yeah, and that's, it's an interesting question because it ties to the difference of what existed before the Space Force was created versus now. And oftentimes people forget that there were decades of heritage with Air Force Space Command back before 2019. And initially, the Space Force was taking up a lot of those missions and responsibilities. But then it became known over the last 5-6 years that we need to expand the scope of the kinds of missions and operations we have to do. And we need to redefine our own culture, redefine how we think about space as a domain. Because for many decades, space was very docile and it was seen as a safe arena to operate in, which is no longer the case. And so the way that I bin it is on one side, you have us as a supporter to all the terrestrial services. So you've got Marines, Navy, Army, Air Force, providing position navigation timing signals. So, GPS, for example, missile warning, missile tracking data. You've even got, satellite communications. But then you have the second bin, which has been evolving lately, which is how do we operate to protect these systems in space? How do we become more agile and maneuverable as we're seeing more kinds of threats in the domain?
Let's start with space stations.
Mhm.
What's the future after the ISS retires?
Well, I think it's an interesting arena because I think it's going to be commercial first. It's been well known that the ISS is going to be achieving its mission life here in a few years. And I know there are companies out there building habitable space stations like VAST, which just raised a massive, I think, $500 million round. The Space Force, as of now, doesn't have a mission for, astronauts or guardians in space that I'm aware of. But I do think as space infrastructure gets built out more over the next couple of decades, that those things are going to become more relevant. And the kinds of technology that we're developing now for just satellites, like, detecting debris, trying to maneuver away and do that kind of autonomous station keeping even, or missions like space domain awareness, where you have to keep track of what's in space at different orbits, how fast are they going, where are they going. I think the more people that over the next generation are going to be in LEO, in space, those technologies are going to transfer over. And then, it's going to be a massive opportunity.
There's also the concept of microgravity platforms used for pharma R&D, also for semiconductors. How do you see the future evolving? Is there a role for the Space Force?
The one thing that's been interesting to see is the dual use aspect of different technologies, right? So there are companies out there that are dedicated to using microgravity for things like pharmaceuticals, right? But the whole point of that is to bring it back down to earth, right? And keep it safe. And so you're seeing a lot of use cases evolve where if, could you bring down supplies? Could you do that kind of from space to ground delivery systems? There are use cases that one technology could be used for two very different things. And I think that's something the Space Force has been trying to evolve with, is you have all of these commercial opportunities that are good for companies to bring in, investment dollars and to grow. How do we as a service use that commercial technology and modify it slightly for our own purposes so that we establish this, in a way, a virtuous cycle between the commercial side and all the investors there with our own capability needs.
Space traffic and debris mitigation, is that a priority for the Space Force?
Well, I can definitely say that it is something that comes up a lot. I mentioned space domain awareness as a mission earlier. That's, I think, becoming more and more prevalent of a thing to keep track of, right? Because just a few years ago, you had only so many objects and satellites to keep track of, or even debris events that you might have to keep track of as well, like for the astronauts on the ISS. But over the last 5 years, we've seen an exponential increase, mainly driven by Starlink deployment. But with all these FCC filings, you're seeing thousands to up to like 1 million objects that are going to be in LEO, then in potentially MEO GEO. And so we need a lot more quicker turn and agile technologies that can tell us where everything is, track it more with higher fidelity, more appropriately, so that we reduce that risk of unintended collisions. Yeah.
Major consideration of latency is we have to downlink data to legacy ground terminals, process it. How can space data centers reduce that latency?
Yeah, I think there's a lot of different ways to tackle that. So in that piece that I wanted to put out there, I've been hearing a lot of debate about the feasibility of ODCs, the economics of it, the technology challenges. But it's mostly through the lens of commercial cloud or AI or AI model training and inferencing. But if you strip back the fundamental architecture of what that can provide, it can solve certain things, in my opinion, on latency and bandwidth constraints. And we're seeing a lot of companies trying to pivot or attack different parts of that value chain. So you have architectures in LEO that are comms based or that are remote sensing or SDA applications. And so if you're trying to increase the amount of data that we're collecting or transmitting through the space layer, then you need native AIML capability in orbit. And so in that piece that I posted, I mentioned the OODA loop, which is a typical military framing of how everything happens from detection all the way to action. And so moving as much of the earlier part of that in orbit as possible so that you can process in space and you avoid those constraints around bandwidth and latency to understand what you're seeing and what to do with that information. Moving into the space layer allows you more flexibility in trade space to act. And so that's kind of like from a more of a military utility perspective. And I think there's a lot of commercial use cases for that too. You're seeing companies that are either doing or trying to vertically integrate their own networking capability to products they've already been developing so that they have a constellation that can very quickly transmit data from one satellite to another through optical laser links, right? And orbital data centers is one way to think about it, but you're also seeing companies that are trying to build out low-cost proliferated ground sites so that you can rely on less ground sites and you could still receive data more rapidly.
As edge compute becomes mission native, where do we see the biggest transformation?
Yeah, so other than specifically military use cases, so you have things like space domain awareness, you have different kinds of tracking. You can also have remote sensing where you're collecting a lot of information on what's happening terrestrially and then passing that along very quickly. You could also think about long horizon. Once we're doing more things in cislunar space, more lunar, even, dare I say, Mars, you're going to have more and more of those latency concerns, right, of getting information back and forth. So having edge processing on board in orbit it allows you the opportunity to stay as connected as if something was in LEO, if you're talking about more deep space. And that has, human spaceflight applications, if we're talking about NASA, or for if you're trying to do rendezvous and proximity operations, station keeping, refueling, things like that, then developing technologies that allow you to have the processing capability closer to the activity reduces the difficulty in transmitting through that data pipeline that space usually gives, because space is, a very difficult domain. to operate in. And a lot of the things that we're seeing, both from the military side and commercial side, are very new. They've never happened before. And so, similar to how you're seeing edge processing become more of a thing terrestrially, companies like Armada or Shield AI, you're going to see the same kind of thing transfer over into space because every domain can benefit from that capability.
An advantage of hosting data centers in space is the ubiquitous solar source. What kills this thesis for lunar industrialization?
So, as far as, if you're not in a sun synchronous orbit in Leo, I have seen a lot of movement in the direction of combining two separate verticals right now. We're seeing more companies that are focused on space-based solar power, either reflecting sunlight, generating power on board, and you're seeing the major drive in ODCs. I have seen discussion of what if we can somewhat power these solar panels on pseudo ODCs with space-based, space-generated solar power so that you're not reliant on being in a certain orbit to achieve that. And I think as the technology matures, as the business model gets built out, and as we go into new and more difficult orbits, I think both of those technology areas are going to interact a lot more in the mid to far term future.
You alluded that the Space Force prioritizes being agile in space. Where do you see the biggest area of opportunity?
Refueling has been a interesting topic over the last couple of years, namely because whether or not you want refueling in a certain architecture or not, that changes calculus over different things. For example, if you're talking about things in Leo, in my opinion, the refueling case makes less sense because, over the last few years, we've been pushing this premise that we want attritable, low cost, easily replenishable satellites, right? And so does the business case close that you're going to refuel these satellites if they're designed to be low cost, cheap, and expendable? However, if you're talking more about MEO going into GEO and XGEO, then that case becomes more relevant. You have more custom dedicated satellites there, longer mission lives. They have to be there longer, do more missions. And so given that, the refueling case makes more sense. And we've been seeing that sort of bifurcation in those two lanes. Namely, there have been or will be experiments using different kinds of refueling modules from different vendors to test out, is one more effective than another. You're seeing new programs that will incorporate refueling capability, but obviously not in Leo. And I think typically, as far as the Space Force goes, first we want to experiment and see, down in RDT&E land, does something make sense? Should we invest more in a certain capability if it makes the entire architecture make sense? And then, given a certain orbit, do we want to become dependent on these refueling capabilities or refueling depots, or does that create certain bottlenecks that we don't want to deal with? And so all of these architectural trades are always being analyzed and thought about. And I think as more and more analysis is done, as more and more R&D dollars are deployed over the next couple of years, we'll see which use cases, both commercially and on the Space Force side, make more sense. I think the technology has always been there. For many years now, we've seen different R&D organizations funding this sort of thing. The problem always comes down to that transition point, also colloquially known as the valley of death, of going from R&D to procurement. And so, like I mentioned earlier, R&D is fine and it helps us understand better which path to go down. That decision to go to procurement is typically a lot more challenging to cross because you have to have a lot of analysis backing. Does it make sense to invest that much more money and then be constrained over a longer time frame to those requirements? So as far as refueling, I think it's been more of a budgetary issue because the technology is nothing new. You could definitely make the case that you would need technology that's a lot cheaper to enable that to make sense, which would then help drive down the budget issue. And that's also what a lot of the experiments we're seeing lately is trying to burn down the risk on.
What is common to founders, or what traits are common to founders who have successfully survived the valley of death?
Yeah, there's a lot of things to say about that as well. But one thing I think is it's to understand that, especially if you're not coming from a background in aerospace or defense, or you weren't in the Space Force or in the military prior, and you're very new to all this, it's to understand that typically if you go sell something to a commercial entity, the buyer is typically also the user, right? But you have to keep in mind that if you're talking to operators and end users to collect their needs, understand if what you're developing makes sense to them, if they would use it, do they like it? That's all great to help refine your product. But a lot of the time, the decision makers on are we going to fund a certain contract in R&D or lower TRL? Are we going to mature that into procurement and production scale? That's in the acquisition community. And so you have to tackle both of those at the same time, which is what I've seen has been most successful, because it's great to have a relationship where you learn from the government perspective, but you can also inform them on, hey, have you thought about using this technology for this use case? And having that, it's more of a conversation, right? Because sometimes the government can be late to the game in adopting certain capabilities. And so making sure you're always having these conversations and you're trying to have them all in parallel instead of one by one or just ignoring one entirely. I think that helps to build up in the government customer's mind of what you're actually developing, where you're at in it, and how willing you are to take their feedback into account.
We have heard ad nauseum that having dual use capabilities is key to land a government contract. What heuristics would you prioritize for acquisitions?
So I've often heard of dual use referred to as a spectrum. Yeah, you often hear that, you know, it's been this paradigm of bespoke, siloed capabilities that end up incurring cost overruns, very expensive, long time horizons. But then you also have commercial off the shelf, just, all right, this company has something, we're just going to buy it and then use it. That's it. But I think there's a lot of steps in the middle. And also, it depends on the vertical you're going down. Are you hardware or are you software? Something that is software is a lot more easy. Hardware, there's more considerations there. Even with software, can it operate in a classified environment? Does it have an ATO approval? And so all those things have to be taken into account. And the other thing to remember is if you're more on the military focused side of that equation, it's pretty tricky because you're beholden to what's called POM cycles, which can take several years to requirements. And so you have a lot less wiggle room when you're interacting with investors on what can you do in the near term to receive revenue outside of R&D, maybe more on the commercial side. And you're seeing that same kind of thesis play out with commoditized bus manufacturing, right? It's that the government might have an interest and they'll fund some of the R&D to de-risk it, and they'll even procure some buses to put their own payloads on it, maybe modify some parts of the bus to fit a certain mission. But in the meantime, while all that is playing out, you can sell to other customers for purely commercial use cases that maybe then don't need any modification, and you can get orders very quickly. And so I think you always have to keep in mind the timelines of one relative to the other and what makes sense to pursue in the near term versus the long term. Yeah, and it's definitely not cookie cutter, cut and dry, not a science. It's more of an art, to say the least.
And can you contrast between a early stage R&D prototype stage company versus perhaps a company with more flight heritage with a couple missions under their belt? What kind of capital can they unlock by working with the government? What do they have access to?
Yeah. So if we're just talking about SBIR sitter, Small Business Innovation Research grants, which is available to every federal agency, SBIRs have often been thought of one way, which is just a way to receive some R&D funding without having to dilute your shares and dilute your equity and take on VC funding. But another way to think about it is it's more than just the money that comes with it. If you win a phase 2 that's 1.5 or $2 million, that's a great win. But it's similar to how if you're thinking about who am I going to take money from in my next round. It's similar with taking on those SBIR dollars, where by doing that, you open the door to having more customer conversations. With a SBIR phase 2, for example, you're then able to get access to more of those conversations and see, hey, in a potential phase 3, which government customers can I go talk to leverage the phase 2 that I have? So it starts opening up this pipeline of more momentum with working with government. And so you also have things like specifically signaling to investors that, yes, there is some interest, but if it is from a customer that has a pretty large budget and wide latitude with how to deploy it, then that could maybe signal there's a lot more opportunity here for, a higher P win on a future contract. There might be a higher opportunity to go for a strategic funding increase or a STRATFI, which I can then take my investor dollars that I've received and put it onto that contract cost sharing with the government. And so there's a lot more, in a nutshell, opportunity that comes with those kinds of contracts instead of just the money on the surface.
How do you see the momentum of government contracts shaping out in the next few years?
Yeah. So in a nutshell, right, I mentioned earlier that every federal agency does have some kind of ability to deploy SBIR money. As far as the Space Force, what SpaceWERX does, which is the body in the Space Force that receives SBIR money and then doles it out to startups. Over the last several years, SpaceWERX has tried to establish better relationships with end users and customers so that as they have needs, whether it's from unfunded requirements or it's from things that are in their roadmaps, we work with them to take that and create different topics and challenges that are reflective of those needs, and working with the program offices and customers to help shape those and ingest those capabilities to fit their needs. And so it always changes and it depends based on the demands coming from those program offices. And so, there's no real shift based on what industry is doing necessarily. It's more driven by what the government needs are. But, in the last couple of years, I think with the increase in connectivity that we have with industry, with the private sector, we're trying to create a more fast moving and harmonious relationship where as things are coming up in industry, SpaceWERX puts on different events, reverse industry days, different kind of velocity events, topic workshops to work with industry to understand, is this ask for these capabilities in line with what industry is poised to deliver now, or should we modify it somehow? And so there's just a lot of ways to improve that relationship.
Public and private collaboration. What accelerates this collaboration?
Yeah. So in my opinion, I think it would be where you have multiple parties having skin in the game, right? Earlier, I mentioned a strategic funding increase or a STRATFI. And basically that is a contract vehicle that allows us to bring in different stakeholders onto that same contract. So if you're a company that just raised its Series A or Series B, you can use the dollars that you received and match that with SBIR money from SpaceWERX or if Air Force AFWERX. And then you can also match that with funding that a government partner is willing to bring in. And this cost sharing arrangement, usually 1 to 1 to 2, up to a maximum pool of $60 million, like that helps to drive conversations forward in a meaningful way where we have better insight into where investors are deploying their capital, which companies are getting a lot of traction. And it helps also investors understand these types of capabilities are something that the Space Force is trying to push for. And so it's very interesting to see how something as mundane as a contract vehicle that has that cost sharing agreement, right, can drive a lot of, alignment between private and public.
There's also companies who partner with companies that work with the government. What can those components or parts companies do to improve their odds of landing these very lucrative government contracts?
Yeah, and that's actually something that's pretty interesting because now you're getting down into deeper into the value chain and deeper into the supply chain where the government itself is not going to buy certain components, right? That goes to a prime on that contract. And it's interesting to see that, let's say a new program is released for several different vendors bidding as a prime, they definitely have to work with those companies deeper in the supply chain. For example, solar panels, different comms equipment, phased array antennas, all those sorts of things. Those major, multi-billion-dollar contracts are also a vector of opportunity for those second and third tier companies. And it's definitely challenging to move from R&D to production or procurement as one of those companies. And SBIRs have been used in the past for that purpose to help those companies succeed while they build out those relationships for business to business. But typically, I've seen a lot more success for those supply chain companies to partner and to still understand the needs of the government and the direction that the service is heading in so they can prepare ahead of time to scale up production capacity. They can go to investors and say, hey, there's going to be this billion-dollar opportunity. Now, we're not going to obviously get the lion's share of that, but this is going to be a sustainable, predictable source of revenue over the next X number of years. And we have already been in conversation with these potential prime performers. And so I think the more and more that happens and the more the Space Force, partners commercially, those opportunities will become more frequent. And we've seen instances like that before, for example, with, the Space Development Agency's proliferated warfare space architecture. And so even companies that are deeper in the supply chain have had a lot of success in that capacity.
Companies are building massive facilities in Washington and California and Texas. There's also companies exploring CNC machining to produce custom parts and components. What is critical for domestic supply chain readiness?
Yeah. I think any kind of component or technology that is typically a bottleneck that increases supplier cost is something that should be emphasized to be either expanded domestically and onshored, or some companies are vertically integrating those components as well. I think there have been instances in the past where RFPs have went out to industry, and a lot of the primes have had long lead times to procure those different components, whether it be solar panels or anything else. And so I think if you just look at those lead times, that gives a sense of, hey, this could be something to go after if you're a new startup, because I can alleviate the time it takes, which also saves cost for these companies. I'm also more competitive in pricing at that point. And so, to avoid specifics, there's a lot of components that need to be expanded domestically. There was even, I think, a Space News article, I think from this week, that talked about, funny enough, orbital data centers, and that there's a lot of components to that have to increase production scale and across the board. And so it was interesting to see, because I typically wouldn't even think about it, that if you're trying to expand this amount of infrastructure in orbit, similar to how we've seen with things like PWSA, you're always going to need to have a very large and sturdy supplier base to hold that up, kind of like a pyramid, right? And I think that was just very timely, because whenever there's a major new wave or thesis around a new space vertical or opportunity, especially on the hardware side, you can't ignore the fundamental economics underlying it in the supply chain.
How many of your vendors are AI native?
Yeah, I think there's been a lot of interesting trend in using various kinds of automation and AI/ML capabilities, from everything from scaling how a factory operates all the way to operations in orbit. I've seen recently companies that try to, and it's fascinating because it's like you can tackle it from every angle. There's a company out there that is trying to use AI/ML to take one kind of code base in a non-aerospace and defense language and transform it into defense use cases. You've also have a company that is trying to automate a lot of the ground floor operations in factories, which seems very disconnected from typical space use cases in companies, but it's actually very fundamental to help drive down that cost for everything from a small component to subsystems to full-on satellite deliveries. Also see companies that are trying to make it a lot easier to test various components and hardware. And I even saw a recent article talking about how one company that's been supplying different primes for LEO constellations, they just did a deal to integrate AI capability to help reduce or increase bandwidth efficiency and spectrum utilization. So up and down the value chain, you're seeing companies integrate AI ML in different ways. And it's more than just what, the mainstream, like you see large language models, all the frontier labs, like that's all one thing. But for aerospace and defense in particular, you're seeing very focused and narrow approaches of how are we going to take this new wave of investment in AI and apply it to various parts of the sector. I would say it is always advisable for AI ML capability to be zero trust and always have some form of human in the loop.
As we see increasing adoption across dual use economies, what's the ROI for Space Force? What's the return on investment?
Yeah, I mean it's pretty huge, right? Because space is inherently very dual use, more so than other services, because you're not going to have a new commercial startup, develop a fighter jet, for example, or a tank. Satellites is something different, or even launch vehicles. I think the way that we give these grants, if we're talking SBIR or maybe OTAs, other kinds of contract vehicles, companies are able to bring that on signal to investors, right? Everything we talked about before. But the government isn't in that to receive any kind of traditional financial return on investment. We're trying to get capability out of it. And so if a company is positioned to grow and scale in terms of production as well, then we're able to leverage what commercial industry does to our benefit. There's always this dynamic playing out where government moves first and then industry follows. But lately, there's been a lot of trend where industry is moving first in something and government is basically following that. But we're trying to get faster and faster to reduce that gap, that delta in between those two functions. And so ultimately, return on investment comes to for every dollar that we give in R&D funding, similar to how STRATFI vehicle is structured, for every dollar that we deploy on these companies in the early R&D phase, we can reap the benefits at a higher multiple later on because we're bringing these partners in the private sector together. These companies are sustaining revenue from their B2B sales, and it's basically comes down to us leveraging what makes us very good, at least in the United States, which is having a dynamic and innovative industrial ecosystem and trying to foster those relationships and aligning different incentives and make it as cost efficient as possible for government is definitely something that's been trending lately.
ISR and PNT, these are legacy technologies. Where do you see the white space?
Yeah, with everything that has decades of heritage, there's always opportunity still. Right. As an example, we've had launch capabilities since, 50s, 60s, right? But that cost per kilogram was insane and it wasn't reusable. And then SpaceX came along. We've had, to use another example, we've had drones since the 80s, 90s, right? Talking about Predator and Reaper drones. But lately in the last few years, we've seen drones thought about in a completely different category for attritable mass and scale. And so then you started seeing companies like Anduril come online to scale that and introduce levels of autonomy and integration using AI between all these systems. It's the same thing with space, right? Like we've been collecting ISR for decades. We've had GPS satellites for decades, but having more resilient PNT infrastructure in orbit so that we are not beholden to these bespoke systems anymore, that's an opportunity. Or understanding that, hey, if I have a lot of low-cost sensors that can have more geographic spread relative to one very expensive sensor that it's, on one very expensive satellite, that's also another opportunity. There have been companies that are, raising a lot of money and winning government contracts doing those things. So it's not always about what's the next frontier technology that hasn't been tried before in space, but it's how do we optimize, reduce cost, and make more efficient things that we've already been doing for decades, but adapting to a new environment that's been, accelerating over the last few years.
As we see this deeper push into autonomy, what's the future of work?
One example to showcase is that as far as the Space Force goes, we're the smallest service, right? Only about, 10,000 Guardians, give or take. And so anything that allows us to increase the ability for each Guardian to function as 2 or 3 or more, that is a large boon for the service. Similar to how, if you're just a company that's trying to onboard some kind of automation, now you don't have to uh, have as many hands on deck, right? So it's a similar case where if we are constrained by the amount of manpower that we have, what are different ways, no matter what it is, that we can um, uh, cover more missions and be more adaptive while not having to be constrained by the amount of operators and people we have.
What message would you share to private capital? How can they plug in the technology gaps where the government simply isn't able to step in?
Yeah, and I think it comes down to having, it seems it's simple, but it's not easy, right? It's having more conversations. It's about leveraging different, whether it's contract vehicles we already have in place or different, things like conferences or events that bring both parties together and being more open in discussing, hey, we have these needs. Here's the scale of what we can deploy. How do we bring in private capital partners into the room and figure out a way forward that benefits both parties? Because obviously, as far as space goes, space as an industry is much bigger than what the Space Force even has budget for to cover, right? A lot of that comes from institutional investors, from private equity, from VC, and they want to see returns on their investment. They want to see exits, M&A activity, sustainable revenue. Always about this spectrum of, like we mentioned before, dual use. Where is a company on that spectrum? What can it feasibly sustain in terms of you've heard of total addressable market, but the military addressable market. And in order for investors to understand, hey, this is what we might see in the next few years, then the service is trying to be more or better in signaling that demand long term instead of on very short time horizons, so that investors can have an understanding of this is what the actual, instead of the theoretical, market will look like as far as the government side goes.
Do you find that there is an incentive misalignment where the government's often working on longer term, decade long contracts versus the VCs in the venture capital field? They're looking for the next big return, but 3 years or 5 years.
Well, I think there's been a lot of improvement in that specific case. It's always a difficulty balancing those different timelines of what's a good return on investment for government in terms of capability and for investors in terms of, financial return. I think that as we've been hearing a lot about acquisitions trying to move faster, being advised to build and buy commercial more often, commercial first if able, based on different requirements. And I think all of that increasingly lowers the time it takes to get to certain acquisition decision points, to certain requirements and dollars being put into different budget documents. And I think that reduces that gap between investors and government. And the other thing that I've seen is investors in space specifically have a tolerance for very long time horizons. And I think if you see the investor side pushing that timeline up, government bring that timeline down, I think we'll see a lot more synergy over the next couple of years with that.
Lastly, is there any technology on your radar that you feel has the future to disrupt space tech in the coming years?
Less so a specific technology, but more of an economic driver. And it's, nothing new. And I think it's well known at this point, but launch cost. I think that's been one of the main drivers for how different decisions on whether it be government architectures or commercial constellations in orbit. That's the whole premise behind Starship as well. Mass has always been a bottleneck in the space industry. And I think, interestingly, if you see cost keep going down, then even something that is the non-recurring engineering that it takes to say, how do we fit something that is this big into a fairing that is this big through, different foldable arrays and technologies, then it becomes a lot simpler of a case to how do we launch more things in orbit? Maybe we don't need to over-engineer certain components given these mass constraints. And I think that will be a major tailwind that will continue accelerating in coming years. It's already been an order of magnitude change just from 5-10 years ago. I think we'll see that continue, especially with multiple launch providers.
Nestor, how can vendors contact you or the United States Space Force?
Yeah, there's lots of ways to get in touch. You've got different conferences, namely to go to and meet people directly. You've got things like Front Door. You have different admin emails that different offices have. It's worth just shooting a message. And yeah, you can find me over email or LinkedIn as well.
This has been Space Terminal. I'm Zuni from Imagining Forward. New episodes are out every week. You can find Nestor Levin and United States Space Force in the show notes.
Thanks for having me on.